Works now.
Okay, cool. So hello, everyone. Thank you for having me here today. Thanks, Wei, for hosting. I do want to make a small apology ahead of time. I have not made it home yet. I was supposed to be home last night, and I'm stuck in the airport. So I am broadcasting to you from Salt Lake City in one of the Delta clubs. But hopefully the background noise won't be too bad. So today I'm going to be talking about unlocking unstructured social media data in marketing. And this work is joint work with Kelly Hewitt at the University of Tennessee, Roland Rust at University of Maryland, and Harold J. Van Herd in New Zealand. And this is work that we did to try and answer a number of questions. And it was motivated by a question that Kelly brought to us. So Kelly was a senior vice president at the Bank of America. And she was really intrigued by the fact that there were certain things that happened when a lot of the bank crises were going on back during the housing crisis of 2008 that seemed to spiral out of control. So one of them was that Bank of America apparently had a situation where they accidentally foreclosed on the wrong house. And they wound up taking everything in the house, as well as a parrot that happened to be in the house at the time, and capturing the parrot and kidnapping it, if you will, right, is what they were accused of. And there's one story written about this, but then that story got picked up by other newspapers, and those newspapers got picked up by others, and then all of a sudden social media started talking about it, and then press releases started talking about it. And what we were interested in, could we build a model of how all these interactions of different types of data interacted with each other, right? Like, how does the mainstream news react to the social media news? How does the social media news react to press releases that might be issued by the banks? And how does that all feed business outcomes? And the manager's perspective in this case is that the media is really an echo chamber, right? You have advertising that's perceived one way, newspapers perceived another way, and social media perceived yet another way, and they all have different durations, they have different lasting effects, right? And they have different impacts on business outcomes. And what we called this is we referred to this as the echoverse, right? So you have firm actions that occur, right? You have some sort of social media word of mouth that spreads about what those firm actions are, whether they're positive or negative. You have the actual business performance outcomes, like, do people continue to work with the bank or not? Do they continue to invest in the bank? Do you attract new business to the bank? You have the news media that covers what's going on, and you have consumer sentiment. Like, there's a baseline level of like whether people think of that bank as a positive or negative entity, right, in the world. And we call this the echoverse because all these things affect each other and they reverberate back and forth across the different channels. And we wanted to test using data how much of this echoverse existed. But very pursuant to the topic of the conversation today, was that that's very difficult to discuss, right? How do you determine whether the news media is talking about the same thing as social media, and whether that's talking about the same thing as what the company is talking about, right? We decided to analyze this, right? And so we decided to take an industry setting of the top 4 US financial service firms, and we looked from June 2007 to December 2013. So we have a large multi-year panel data set for all 4 of these firms. And they're in the US, the largest 4 financial firms are Citibank, JP Morgan Chase, Bank of America, and Wells Fargo. So here's what I thought would be interesting for this particular talk, right, is talk a little bit about the data and how we got it, right? So we have a lot of different data in this group, and this is one of the most massive data sets I've put together. So we have firm communications, which has all press releases, volume, and valence. We have corporate tweets, so Twitter representing social word of mouth, where we're going to classify volume and valence. We have ad spending, so we know how much each of the firms spent on advertising. And we have also other sources. So we have traditional media news stories, the volume and valence of each of those. Consumer sentiment, which is derived from YouGov's Brand Index, which is a panel data set where they pull how popular each industry is, each company is. Social media word of mouth, which is the actual underlying tweets, and firm performance, which we measure as consumer deposits. So how do we actually take that data in those raw formats and process it into something useful, right? How do we unlock the data that was in the social media narratives, right? So we took the press releases, right? And we have 5,376 of them.
Bill,
And we took, yes.
your slides doesn't change.
Oh, the textual data overview slide isn't showing up?
It's always the first page.
Okay.
Okay.
Is it changing now?
Yeah, it's changing now. It has data now.
Okay. Okay, I guess I'll just do it this way instead, right? Yeah. So let me just get, so basically this is where I was talking about where the different data sets come from, right? So here's the slide I was talking about. So we have the textual data, right? And so let me talk briefly about the size of the collections, right? So for the press releases, we had over 5,000 press releases from the different banks. For news articles, we had about 65,000 news articles, and those were provided by Activa, 14 of the largest circulation newspapers in the US. And from tweets, we had about 18.5 million tweets, which we procured from GNIP, which at the time was not owned by Twitter, but now is, right? And so in all these cases, we have essentially the content that was delivered by the company as well as the content that was delivered about the companies, right, that other people had written. Now, the problem with this data, of course, as anyone who's actually done some work in data science realizes, is that manually coding 18.5 million tweets is impossible, right? Both to do the volume and the variety of the data. Press releases, for instance, are in Microsoft Word format often, PDF format often. The news articles were often downloaded and pasted into a Word document, and the tweets were in JSON format, right? So we needed to do some sort of automatic coding automatically. So we used computational linguistics to do that.
For the tweets, do you give tweets by keywords? Just search
So GNIP pulls tweets by keyword, and so we delivered a list of keywords to GNIP, which they then used to pull the tweets from the historical data set. In this case, we identified about 5 to 10 major Twitter handles for each of the banks. But then we also gave them about another 10 words for each of the banks that were like the formal name of the bank, the name of the CEO, things like that were used also to extract data. So, but we didn't use any of the publicly available tools. We bought that data. Now, we've also used publicly available tools in other explorations, but in this particular case, we paid GNIP for the data.
Is that expensive?
It is relatively expensive, especially for 7 words. We're talking on the order of thousands of dollars. Let's put it that way. So they gave us a little bit of a discount because we're an academic partner, but other than that, they did, it was pretty pricey. So once we had all this data, we converted it from the various format, Microsoft Word, PDFs, to plain text, and JSON as well, right? And then we extracted from each of those documents the date that the document was posted. So if it's a tweet, the date of the tweet. It's a press release, the date of the press release. We also, in many of these cases, had to identify the associated bank, right? So several times, maybe in an article, there might actually be multiple banks identified, in which case we identified it as coded as being part of multiple things. And then we had to do sentiment, which is what I'll talk about in a little bit in more detail, because it turns out we had to do that differently from each of the different data sets, right? We're then going to aggregate that data at the weekly level for each data set. So let's talk a little bit about the Twitter data set in particular. So we used, as I was talking about, we used 72 different power track searches from GNIP is what they're called. Roughly around 15 to 30 different search terms, right? Some more easier than others in some respects. We had to, of course, work out what those were. So for example, we used different bank Twitter accounts and mention of those accounts. So Merrill Lynch is related to Chase Manhattan, for instance, so they're included in here. Bank of America is another one, even though it's not used, but people tend to type it out sometimes to mention it. And then references banks. So Bank of America is often related to BAC or BOA, right? And then reference the executives and references to the various products. And in all cases, we chose the terms to minimize the probability of false positives, but to gather as much as possible data. So trying to maximize recall and precision. And we did some kind of false positive testing, and though we had some in the data set, it wasn't too high, and it seemed to be independent of the different banks. In other words, there wasn't one bank that would have more false positives than another, which made it led us believe that we could go on with the data analysis at that point. So for the press releases and news articles, we did a simple sentiment analysis using the LINQ tool, which is the Linguistic Inquiry and Word Count tool. We used the 2007 version, though there's a newer version that's been released so far. That tool essentially contains a dictionary of positive and negative emotion terms. And so what we can do is we can go through and stem all of the words in the documents and then match them against those terms. And so, for instance, ugly and ugliness both map to ugh, L star. And so we stem all the words in the press releases and news articles, and we just count up the number of words in each of those documents. The output of that is a percentage of positive and negative words and the overall word count, right? And that's how we're going to measure whether the article is more positive or negative in this particular case for the press releases and news articles. Now that works really well when you have long form text, right? Because you have lots and lots of text that you can analyze. And the press releases tend to be a couple of pages, news articles tend to be a page. There's enough in there for us to build out. Twitter, on the other hand, uses a much shorter set of tools, and it has has a lot of its own peculiarities. So, for instance, there's a lot of misspellings in Twitter, right? Hapnius Citibank with the I instead of the Y. There's acronyms like LOLs, meaning laughing out loud, right? IMHO, in my opinion, right? And dropped characters, right? And so we had to, instead of using a stemming tool as before, we instead used a tenfold cross-validated naive-based classifier that's based on this work by Go, Bayani, and Wang from 2009. Essentially what we did was we extracted tweets that had smiley faces and frowny faces from the data set, used those and classified those as our gold standard of positives and negatives, and then we were able to classify overall the positive and negative sentiments of the tweets, right? Of course, the tweets had to be pre-processed, removing white spaces, adding a feature set, featureization for all caps, because that is essentially equivalent to screaming, and then lowercasing everything. We removed big punctuation, removed repeated letters, removed common stop words. In the end, we wound up with about 8,000 features, which included the common words, timestamps, and links. And then we can output a score of -1 to 1 to measure how positive or negative the tweet is. So once we had all this data and processed, we then summed up the sentiment scores associated with the tweets by bank by week, and we counted the number of tweets by bank by week. We can then separate out tweets from the bank versus tweets by others by looking at who were the original Twitter users who had generated the tweets. And that allowed us to only take into account tweets about the banks rather than generated from the banks. We also, for the press release and news articles, we summed up the percentage of positive words minus the sum of the percentage of negative words to calculate the valence, and we counted the number of documents by bank by week. I haven't mentioned the unstructured data, but we also had consumer sentiment data, which was a structured data set, which basically told us at a weekly level which of the following banks are in the news according to the best opinion of the people being surveyed. Are they in the news in a positive and negative way? And this is averaged across thousands of responses per week. What we found when we looked through that data was that we definitely found evidence at a naive level of the echoverse at work. So in the case of Bank of America, right here, I'm showing Twitter volume over time, news article volume over time, and consumer sentiment over time, right? And this gap right here where everything spiked is actually related to an announcement by Bank of America that they were going to start charging a debit fee for their ATM cards, right? A monthly transaction fee for their ATM cards, right? Their debit cards. And as you can see, Twitter volume goes way up, news article volume follows it a little bit, and consumer sentiment goes down around the same time, right? And so this was kind of a, if you will, a model-free indication that our ideas about the echoverse actually happened. I should mention, by the way, also, this is something that will become apparent in this data set as we talk through it, but 2007 is really only the beginning of social media and only the beginning of Twitter, right? And so the volume on Twitter is going to go way up as time goes on, though the volume in news articles and in the press releases is going to stay relatively constant over time. So here's how we conceptualize the brand echoverse then, right? We have the online word of mouth as evidenced by Twitter posts, the business outcome as evidenced by customer deposits, the consumer sentiment as evidenced by the brand index, traditional media news stories, and firm communications as evidenced by press releases, advertising, and Twitter posts, right? And we kind of are looking to see how these different channels affect each other over time. How do we actually analyze this data once we had it? Well, the echoverse conceptualization says that all the variables are endogenous, right? There's a time lag that exists and that one lag turns out to be an optimal level. The appropriate methodology then from the statistical world, and Harold is really the expert on this, he did all the work on this, is the VAR model, which is a vector autoregressive model that allows for individuality between all of our variables. We then use this model to calculate generalized impulse response functions and looked at the effect of shocking one variable. This essentially allows us to see if we were to perturb one of those variables by a standard deviation, what would be the effect on the overall system? And it takes into account all the repercussions within the echoverse of the different effects that might occur. Here's the actual estimation equation that we used, right? Or a version thereof, where we are regressing the outcomes on the previous outcomes, and we're controlling, of course, for fixed effects for the banks, competitor actions, consumer confidence, unemployment rate, and a various variety of other actions that might have happened. But this is basically all the data sets that I've talked about. So let me talk a little bit about the results, and we'll finish there for the day, right? So first, the bad news. The bad news is that we find that bad news spreads fast and wide, and that online word of mouth hurts firm performance via customer deposits. So the more negative news articles that we see, the more we get public tweets that talk about those news articles, right? And this is kind of what we saw originally, where the Bank of America's kidnapping the parent resulted in a bunch of news articles coming out of it. The more negative public tweets also lead to more news articles. So this echoverse happens very strongly back and forth when it's negative, right? So that's kind of a bad thing. It says that the echoverse happens and that there is a huge effect on.
How do you know which leads to which?
So in this case, they both lead to each other is basically the answer, right? So if we perturb the system with a spike of negative public tweets, we see more news articles. If we perturb the system with a spike of negative news articles, we see more public tweets, right? They both happen simultaneously, and it kind of depends on where the story breaks first in many cases. We're doing some follow-ups where we kind of try to see, is there a way to predict ahead of time which of these is going to cause more problems than the other one? But in this study, at least, we weren't able to isolate that. So the other thing is that these more negative consumer sentiment and more negative company tweets also lead to more news articles. So obviously this makes a lot of sense. If consumer sentiment, if people in general feel negatively about what's going on, that causes more news articles. And if the companies are outputting a lot of negative tweets, that also leads to more news articles overall, right? So this is basically one thing to say is that the companies can actually cause themselves problems by generating more negative publicity about their own actions. And that will show up later on as well when I talk a little bit more in detail about the results. So online word of mouth also hurts firm performance, right? So no matter what we find is that if tweets are becoming negative, right, that hurts firm performance. That customer deposits tend to go down following large online word of mouth negativity spikes, right? So what can companies do in this space? Well, there's some good news, right? And the good news is that press releases are surprisingly effective even in today's age, right? Now, this might surprise some people because they might think that the press release is dead. Who releases these standard one-statement articles, right, and leaves them as that, and that they don't really affect anything. But the truth of the matter is that press releases are no longer just for the press. They're picked up by individual readers who find them, like bloggers who find them and post about them, individual consumers who want to check out what's going on in a news article and find out if the company has anything to say about it. And they are basically circulating among all the individuals out there, not just the press anymore. So this gives companies a way to bypass the mainstream press and talk directly to the consumer. So more press releases seem to result in more positive news articles, more positive word of mouth, and higher customer deposits, right? So having a good and strong press release strategy can really help you to combat negative word of mouth that might exist within the Twitter sphere. However, the press release strategy actually matters. So what we found, for instance, is that Wells Fargo kept releasing press releases all the time, talking about the positive elements of their company, talking about what's going on. Bank of America, on the other hand, would lay low and only release press releases in response to negative events. That turned out to have a very negative impact on their overall strategy. It wasn't successful in creating that positive word of mouth that I was talking about before, whereas Wells Fargo's strategy worked out much better. Also, and this is talking about the unstructured data, the press release language matters. So as I mentioned, we can not only classify, as I mentioned, we use the Luke tool to classify the valence, but we can go beyond standard valence. Luke also contains a set of dictionaries related to things like sadness, anxiety, anger, tentativeness, and things like this, money, future work, that we can also use to classify the language of the press releases. What we did was we classified all the press releases that Bank of America issued and Wells Fargo issued. In fact, we classified all the languages of all the firms, but Bank of America and Wells Fargo in particular seem to have a particular set of policies here. From my earlier discussion, if I go back up to it, Bank of America seemed to have a bad strategy because they laid low and watched, whereas Wells Fargo was always out in the open, right? And in fact, if you look at Wells Fargo's press releases, their press releases tend to be much more focused on things like money and work and what they're planning to do in the future and things like that. And those press releases worked very well, right? Whereas Bank of America's press releases focused on anxiety, anger, negative emotions, and other actions that didn't have as good of an effect. And they tended to react to negativity in the media rather than leading it. We also found that company tweets can calm things down overall. The more company tweets you create, the fewer news articles you see, and the fewer articles you see from other word-of-mouth users, right? And so if you're constantly on the forefront tweeting about what's going on, that can help to overall satiate what's the need for news and prevent a large bad news spikes from occurring. But similarly to before, the Twitter strategy matters. And what's interesting here is that Wells Fargo and Bank of America switched roles here. Bank of America actually has a really great Twitter strategy. Their focus is on greater value with more personalized tweets. They're really focused on customer service, and the overall tone of their tweets are more neutral. This makes it more of a conversational space rather than a promotional and selling space. Wells Fargo, on the other hand, has a very low volume of tweets that issued. They were more directed at a mass audience rather than an individual, and they tended to be more promotional, advertising, and positive tweets, right? That had a negative reaction from both the news articles and the overall level of company word of mouth from the rest of the customers. Finally, it turns out that advertising bypasses the echoverse completely. So increasing spending on advertising seems to bypass the echoverse, right? So increased spending on advertising had no impact on news articles, no impact on word of mouth, and no impact on consumer sentiment that we could detect. But it does seem to relate directly to customer deposits. So increasing advertising had an effect on where customers decide to deposit their money, even though it didn't seem to influence any of the intermediate channels. So that's about it. Actually, I ended a little bit early because I knew I have to go catch a flight. And so I still have some time for a few questions before I have to dash out the door. But thought I'd go through that and see what you had to say. Thanks.
How you connect the word of mouth to the actual deposit? You have data linked together for advertising.
So let me go back.
How you link that together? How do you know because advertising?
So the way we know, right, if you go back up, is that we actually use this model, right? So first of all, let me take a step back. All the data is date posted, right? So we know exactly when, it's at the weekly level. So we know at exactly what week, how much money was spent on advertising, right? So when we're saying something like, advertising seems to result in increased customer deposits, what we mean is that there seems to be a connection directly between, let me try and find it, directly here between the firm communications and the business outcome, right, that shows up again, 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 no matter what's happening in these other spaces. And this is because we're using this vector autoregressive model where we're basically regressing all these variables on each other and looking at all the possible relationships between them. And what that gets out is what is the overall impact once you, and the best way to look at these results is to think of, if I were to perturb advertising by a certain amount, and I allow all of that to filter through all the different channels that could possibly affect, what will the eventual outcome be on the business outcome? And what we find is that it has a non-zero outcome in the end on business, on customer deposits. Even though it has an effect on Twitter and it may have an effect on traditional media stories and consumer sentiment, that effect goes away over time. But what we find is that there's a continuing and sustaining effect on customer deposits. So we're using this model right here to kind of look at all the relationships between them. Does that help answer your question, Claire?
Yeah, and I have another. How fast is that natural language processing when you string the words? Is that fast? If you have that big amount of text data, it will be very slow to process it, right?
Yeah, you know, I don't actually have the exact stats with me as to how long it took, but honestly, it takes more time to get the data in the right format than it does to actually process it, to tell you the truth, right? You know, just pulling out just the right text and having it dated and having it in a folder where we can like just quickly process all that data. I mean, the naive Bayes classifier on an individual tweet, it takes microseconds, right? I'm guessing you're probably able to run this through in less than a day or so on all this data, right? In all the different ways we did it. What took the longest time was just kind of figuring out what's the right format, how do you featureize it all, what do you do with it, right? And then once we had all that done, the actual processing time was very small.
Okay. So
I'd say, much like a lot of data science, right? Like, I feel like 90% of the time was spent cleaning the data, and 10% of the time was spent analyzing it, right?
Thinking about what kind of method gonna be proper for the analysis. Once you know what model you use and you have the data, it'll be very quick. Just some line of code.
Exactly. Luke runs very fast, even on large document sets. We don't know, like the one thing I will mention is Luke is a commercial proprietary tool, so we don't know. Well, it's not if it's commercial. It's developed by a set of linguists, so we don't know the exact dictionary it's using, but it's essentially doing a dictionary match where it's processing the data and just matching a word against the data. So it runs very fast, right? And the naive Bayes classifier is essentially doing the same thing, but then it's also doing a quick calculation of the probability that that is a negative or a positive tweet, essentially, right? By summing up across the naive Bayes features, right?
And if a company want to start their analytics, they have to get the data at first place. And if they want to make it useful, they got to have an automatic way to collect the data, get everything into a pipeline.
Yeah. So there are a number of tools out there. We actually make one tool available. It's called Twitter Eater. And if you go to GitHub / Center for Complexity in Business, which I know is really long, but if you go to there, you'll actually, and I can actually put it up here real quick on an empty slide. I can't do it easily, but I can provide you with that link that you could put up in the notes at some point.
Sharing your slide.
Yeah. So
sharing and share your browser.
Yeah.
Browser.
Yeah. Let me do that. I'll switch it off. So let's see. Wrong way. Hold on a second. Okay. Did it share it over there?
No. Yeah. Now it's you.
Yeah.
So can share.
Okay. So you should see it now.
Yep. See it.
So github.com / Center for Complexity in Business, which is where I used to be at the University of Maryland. We'll probably reflect these over to my new center eventually. But right now you can go to Twitter, which is the Twitter Eater. It's a tool that's set up to work with MySQL databases, fairly easy to use, publicly available, open source project that will allow you to basically generate some config files to have a set of keywords, and then automatically collect all the tweets you want. Now that's going forward, and it is limited by Twitter's public API rate limits, which are about 1% of the overall Twitter feed, but that they will provide you with a good set of data by which you can do the analysis. In this particular case, because we wanted to get historical access to the tweets, we weren't able to use Twitter, right? We had to go, because we wanted to go back in time. Twitter will only work going forward, right? And so as a result of that, we had to contact Gannett to see about purchasing the data.
So about those news data, we probably just have to purchase it.
Yeah, news data is even harder to get, honestly. I have a new project that I'm working on. The one thing I might suggest, if you want to look into it, actually makes it available that will allow you to search data. That's the one place that we found that will allow you to collect data. We are working on trying to modify Twitter to also use the Bing News API to collect multimedia print mainstream news data for you at the same time. But we don't have it completely done yet. But we have written some other tools. I know there are some tools available in Python that will use the Bing News API for you automatically. I don't know if there's any written in R in particular, but I'm sure someone out there will find a way to do it. It's pretty easy to do. And in terms of the press release data, honestly, for that data, we actually had grad students who collected a lot of that. So, but if you wanted to collect it automatically, most companies should have that data about themselves already, obviously, right? But it'd be pretty simple to use something like Beautiful Soup to collect that data automatically from a company's websites. So Beautiful Soup is a great if anyone hasn't used it, it's a great Python package that allows you to automatically collect data from a wide variety of HTML source files.
So that's scraping. You can scrape the.
Yeah. So I'm talking about scraping the press release data.
Yeah. And if a company want to build a team to do that, what kind of talents they need? They need data engineer, data scientist, and some other.
Yeah, I would suggest, right, that they look into hiring some statisticians, for the modeling part, right? Because I'm not trained very well in that aspect of it, to tell you the truth. Some computer scientists to do the web scraping and AI components. And of course, it's always useful to have someone with some business acumen on the team, right? Someone who has some knowledge about how these variables might work with each other. working with Kelly Hewitt, who had a lot of knowledge about how the banks actually make these decisions, and Roland Rust, who has a lot of knowledge about the underlying marketing theory behind a lot of these decisions, was invaluable in building and generating this result.
And another challenge for traditional company, like non-technology companies, we cannot link those sentiments to our purchasing. That's very hard.
Yeah, that's a very difficult thing to do. And unfortunately, unless you're able to collect the data directly from the consumers who are making the purchase, and some companies have looked into this. So for instance, Amazon ran a special where if you gave them your Twitter handle, right, they would give you a $5 MP3 credit, right? And that would allow them then to track, link exactly your tweets directly to your purchase behaviors and your loyalty method, and your loyalty actions, right? I've also seen other companies that basically started contests where they have you tweet out, something to get a $5 discount, and then once they tweet that out, they can try and connect that tweet that you sent out directly to your loyalty data, your purchase data, and so on. So it's possible. It's not easy to do.
Yeah. Other than analyzing the sentiment, is there any analysis on how people are linked together, how the message spread out? So if we want to tweet something, we want everyone to retweet us, what strategy should we use? And who we need to involve, and how to measure the involvement?
Yeah, so unfortunately, that's like a whole nother discussion. I'd be happy to come back on and talk that with you. I can point you to some other papers in that space. I would recommend looking at some of the work on influencer marketing and things like that. I have some papers, and here, let me just quickly pull them up. If you go to SSRN, which is, let's type it, which is the kind of preprint for social science research. There is a number of different spaces about trying to track kind of diffusion modeling. Hold on one second. So this is back at the Center for Complexity and Business again. And I might specifically look at like things like our paper on influence in microblogs, right? Or all the way back down to some of my oldest work in this space, which talked about evolving viral marketing strategies, right? Trying to come up with good strategies to figure out who to market to and underestimate that influence. Unfortunately, I really don't have the time to talk about that today in too much detail. I recommend, there's great work in the marketing literature on influencer marketing and looking at word of mouth in social influence. I think that's a good place to start. Okay. So unfortunately, I think I have to get to my flight. But thank you again for hosting me, Wei, and thank you all who are watching for being part of this, for sure.
Thank you, Bill. Thank you, everybody.
Yeah. Thanks. Take care. Bye.